Okay, so I have a triangle, and you see how I extended a line. So everyone pay attention here. I extended this line, and this angle formed outside, this obtuse angle in this case. Doesn't have to be obtuse, but in this case it is. Um, this is called an exterior angle because it extends from one of the lines, the segments from the triangle, and it's formed on the outside. And remember that word we use in geometry starts with an A when things are next to each other? Adjacent. So the angle is adjacent to one of the angles. This angle here. Okay? So it's adjacent to this angle. However, you see these two angles it's not adjacent to? They have kind of a cool name. I need you to pay attention. These are called remote interior angles. Remote interior angles. What does remote mean? When something is remote, like if you're reading a story and they say the castle is so remote. Yes. Huh? Oh, not that kind of remote. I never thought about like remote control. Not that kind of remote, but it kind of has to do with that because when something's remote controlled, are you usually right? Is it in your possession? Is it right there? It means far away in this case. But it kind of has that connection with remote control because something has to be further away for you to control it remotely. And that's what that means. So it means far away, not adjacent. So the two angles that are not adjacent are remote interior angles. And there's a reason I want you to understand that. Okay? So these are my two remote interior angles. But I could just change it real easily like this. There's my triangle. These two are my remote interior, and this one's adjacent to the exterior. So it's always, what's the relationship to this outside angle that we're looking at? So these two are remote interior to this exterior angle. Okay. However, if I take this one to be my my exterior angle, so if this is my outside angle, exterior, then these two are my remote interior angles because they're not adjacent. They're not connected. And this is my adjacent angle. So the angle that's connected or adjacent or sharing a common line, if it's sharing a common line with an outside angle, it's adjacent. We are interested in the ones that are not adjacent. So I'm going to go back to this setup. And here's what I want to do. Kind of what I did before. I'm going to take these and deconstruct. There's one. There's the other. And if I take these two angles now and think about what we did yesterday or what I demonstrated yesterday, how do you think they would fit to the exterior angle? Would they fit perfectly or would there be some extra? Let's check. So here's one. In fact, I think it's easier if I do this. And here's the other one. And I'm shaking a little bit, so it's not perfect, but can you see that it's a perfect fit? Yeah, it's a perfect fit. So these two remote interior angles equal the exterior angle. And that's what we're going to explore today. That's called the exterior angle theorem. So math is all about rules and theorems, and we're going to learn a new one and use it a little bit. So everybody got their notes out and whatever you use for your all right. So let's go ahead and get started. All right. So this time we're talking about the exterior angle theorem. Okay. Um, Anthony, can you read the exterior angle theorem, please?
The measurement of the exterior angle of a triangle is equal to the sum of the two remote interior angles.
All right. So what it's saying is this angle here, angle 4, that's the exterior angle, is equal to angle 1 and angle 2 added up. And there it is. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So it's important to identify, okay, which is my outside angle? Now, which two angles inside the triangle aren't adjacent to that angle? Because if I add those two up, it equals the outside angle. All right? And that's what we're going to be working with today. Any questions? So here's your first task. I want you to figure out the measure of angle x in each of these. Okay? So take what you just learned, see if you can figure out the measurement of angle x. I'll give you a little bit of time. So they're telling us the measurements of the remote interior angles. Okay? So this angle here, angle y in this case, that's adjacent. We don't want the measurement of that. We want the measurements of the two that aren't adjacent. This guy and this guy. So basically 60 plus 80 is x. So that's 140. So this outside angle is, exterior angle is 140. Okay? So same thing here. We got our adjacent angle. We don't really work with that one. We work with the two that aren't adjacent. Those are the remote interior. So this time it's 75 plus 36. How much is that? Q. Great job. Yes.
So would you also be able to use x to find y?
Yeah, we can use x to find y because now we know that this is 140. Yeah, this has to be 40. Yeah, if it comes up. So definitely we could figure that out. This has to be 40. And there's two reasons. Well, they're kind of the same reason. All three of these have to add up to 180, and these two have to add up to 180. So the same reason for both. But yeah. Bless you. All right. Okay. So for the next one, we want to find the measurement of angle C and angle D. So we want to figure out how many degrees each of those angles are. And right now we just have expressions for those, right? We have for angle C, it's 4 times y. And for angle D, it's 7 times y plus 6 for those measurements. But we do have this exterior angle. We know that that's 116. How can we use that to figure out, first of all, what y is, and then once we know what y is, we can figure out the measurement of the angles. Yeah, we got to add these up. We add these up. These are the two non-adjacent angles. So we add up, we create an equation. So much of what we do and especially next year, is going to be stuff like this. We know that 4y plus 7y plus 6 equals 116. And then we just combine the like terms. So 4y and 7y. Let's see, that's what? 11y plus 6 equals 116. Um, let's solve it. So take away 6. 11y equals 110. And how many times does 10 times? 11 goes into 110 10 times. Okay. So, sorry. There it is. That's just what y is. But we want the measurement of these angles. So we want the measurement of angle C. And then the measurement of angle D. How can we find that? We want to know how many degrees each of those are. So far what we found is that y equals 10. Hmm? Yeah. Well, yeah, remember, angle C is 4 times y. So couldn't we say this is 4 times 10? Yeah. So it's 40 degrees. And then we could do the same thing for the measurement of angle D. It's 7y plus 6, so this is going to be 7 times 10 plus 6, 76. So there they are, 40 and 76 degrees. All right. Any questions? Yes. Well, F is it in itself isn't an angle. It's just a point. The reason we can call this angle C is it's an angle and the vertex is C. The reason we can call this angle D is it's an angle and the vertex is D. But this is just a point by itself. So we really can't. Same reason we can't say angle E, because E could be this inside angle or it could be the outside angle. So for those, we would have to be real specific, like CED for the inside angle or DEF for the outside angle. Okay. And that's definitely the type of testing questions they would ask you on the SBAC. So that's a good point to make. Thank you. All right, let's try some more, guys. Find the value of x and the measure of each angle. Ooh, so this one's different. They're not giving us points, but we want to find the measure of each angle. So you guys ready? So how can we have to set up an equation, right? What kind of equation can we do? We have an outside angle. There it is.
Perhaps we can do x plus 25 plus x plus 17 equals 3x plus 2.
Let's do it. Let's do that. So the two outside angles, x plus 25 plus x plus 17 equals 3x plus 2. Okay, so this is just an equation with variables on both sides. So for right now, ignore the right side of the equation and then just combine anything you can. So if I combine everything I can combine x with x, and then I can combine 25 and 17. I'm 42 equals 3x plus 2. Okay, so that helped us out. Now what do we do? Who remembers when we have variables on both sides what to do next? Ooh, okay. I can't see who you are back there. Giselle.
You subtract 2x from both sides.
Yeah, we could do. You have a choice. You could subtract 2x from both sides or 3x from both sides. I like what Giselle did personally. Get rid of the variable on the right-hand side. Even if we wind up with a negative, I can handle negatives. And at this point, I'm hoping everyone here can too. And so that's negative x plus 42. And I don't know. I'm kind of worried though. Are we going to get a negative answer? That's not good. Are we going to get a negative answer? What's our next move?
We're going to subtract 42 from 2.
Uh-huh. Phew. We're not. Because we end up with negative x equals negative 40.
Divide negative by negative.
Divide a negative 1. Basically cancels the negative. So negative x equals negative 40 is the same as x equals 40. So that's good. We couldn't have a negative answer because then you can't have negative measurements for angles. Okay, so now let's figure out these measurements. Let's start with this one. What's 3 times 40 plus 2? What's 40 plus 25?
65.
So this is 65 degrees. What's
57.
57? And Abraham, here's the part that we also have to figure out this one, right? We could do 180 minus 142, and that's what? There we go. So we figured out all the measurements of the angles. Mhm.
Why is it 3 times 40 plus 2 is 142 if 3 times 40 equals 120 plus 2 equals 122? Why is it 122?
Oh, did I miscalculate that? Yeah, in fact, we can add these two. So let's try that again. I apologize. And that would change this one too. Okay. So let's try that again. 3 times 40 is 120 plus 2 is 122. And what's 180 minus 122? Yeah. Okay. All right. So I'd like you to try this one. Set it up and let's solve it. So we're going to do the same thing. We're going to find the measurement of y again, and then use it to find the measurement of each angle. Okay? So set up your equation and then solve it. You'll find out what y is, and then you're going to use that to figure out the measurement of the angles you don't know. Okay? So I got 28 degrees and 24 degrees. Okay. I would like help for the last question. It says, find the value of x and the measure of each angle. So can someone tell me a possible equation using that exterior angle theorem? All right, Haley, tell me.
You can do 4x plus 2 plus 2x minus 9 equals 5x plus 13.
So basically, The sum of the two remote interior angles equals the exterior angle. All right. So use that to figure out what x is, and then use x to figure out these three unknown angle values. Okay? So this is what we got. You set up your equation, you solve to find x, then you substitute that value 20 for x in each of these expressions to get the three angle measurements we were looking for. Okay? All right. So today's assignment is IXL, and very much like what we're doing here.